So welcome back to KSET previous year question and solution classes. Today I will discuss 2021 paper. Okay, so CMP part. So here question number 79. In a simple cubic crystal, X-rays of wavelength lambda alpha is diffracted from the 100 plane at a certain angle theta and a wavelength lambda b from the 110 plane at the same angle. The ratio of lambda a by lambda b is then equal to. So here we have to calculate the ratio of lambda a by lambda b, or it is lambda alpha, then it is lambda beta. We have to calculate the ratio of lambda alpha by lambda beta. So in CMP we know that to find the wavelength, incident wavelength of a given sample, and also interplanar spacing and lattice constant, so we have a formula. So that is by Bragg's diffraction method, n lambda is equal to 2d sin theta, right? So here if suppose this is n1, if this is alpha, so then it is d alpha, remaining all other same. And next and also for the same, let us take n2 lambda beta is equal to 2d beta sin theta. Let us consider this is equation number 1 and this is equation number 2. Okay, but here n1 is equal to n2, and we know that sin theta 1, if suppose this is 1, this is 2, sin theta 1 is also equal to sin theta 2, because this theta is constant and the order is also constant for the same in the same problem, only lambda and d is changing, right? So to calculate the d interplanar spacing, they are giving d100 plane and another one is d110 plane. So let us take d100 plane is equal to a divided by square root of 1 square plus 0 square plus 0 square, right? Because dl h k l is equal to a divided by square root of h square plus k square plus l square, right? So therefore here d100 is nothing but a divided by root 1. Similarly d11 plane, so here they are also d11 plane. So let us consider d110 plane, which is equal to a divided by square root of 1 square plus 0 square plus 0 square, sorry 1 square plus 1 square plus 0 square, so a by root 2. So this is for d beta and this is for d alpha. So therefore lambda alpha is equal to d alpha and lambda beta is equal to d beta. Remaining all, if you take a ratios, the sin theta 1 sin theta 2 cancel, n1 n2 cancel and 2 cancel. So therefore lambda alpha is equal to d alpha and lambda beta is equal to d beta, and lambda alpha by lambda beta is equal to d alpha by d beta. So therefore lambda alpha by lambda beta is equal to, so what is d alpha? 1 by root 1, and what is lambda beta? 1 by root 2. So therefore lambda alpha by lambda beta is equal to root 2 by root 1, so which is equal to root 2. So root 2 is the answer. So in the given question, root 2 is nothing but option C. Option C is correct. Okay. Next, given below are two lists of items. Match the items in list X with those in list Y. See, in the list 1 we have van der Waals bonding and ionic bonding, covalent bonding and hydrogen bonding. See, this is actually chloride has to come here, potassium chloride. Okay, So and these are the options given. See, we know that van der Waals bond is also weak bond, it's a molecular bond. Van der Waals bond is observed in argon. And ionic bond is observed in ions like potassium chloride. So this is potassium chloride. So in KCl we can see the ionic bonding, and this is covalent bonding. Covalent bonding is sharing of electrons which takes in carbon, and hydrogen bonding is observed in water molecule. So water molecule, this is molecule actually, okay. So therefore for van der Waals we can observe argon, so 1 to A, and ionic bond is potassium chloride, so that is 2 to C, or right, so 2 to C, or we can observe that for 1 it is 1 and for 2 it is 3. And covalent bonding, for covalent bonding it is for carbon, so 3 to 4, and hydrogen bonding 4 to 2, so 4 to 2, we can see 4 to 2, 3 to 4, and 2 to 3, and 1 to 1. So option A is correct, okay. Ionic bonding is example for, van der Waals bond is example for argon. Ionic bonding is observed in potassium chloride like KCl or NaCl, and in covalent bond we can observe in the carbon atom, next in hydrogen bonding we can observe in water molecule, okay. So next question, in a monoatomic linear lattice, the frequency of omega of an acoustic wave is given by omega is equal to kcm whole power 1 by 2 sin ka by 2, okay, where c is the force constant, m is the mass of the atom, k is the wave vector, and a is the lattice constant. Next, the group velocity of the acoustic wave at. So we should remember the group velocity expression. So that is Vg is equal to d omega by dk, okay. So here omega is given, so that is omega is equal to 4c divided by m whole power 1 by 2 sin ka by 2, okay. Next, so we know the expression Vg is equal to d omega by dk. So next let us differentiate this d omega with respect to dk, which is equal to 4c divided by m whole power 1 by 2 is a constant, and differentiation of sin is cos ka by 2. And they are given the condition that k is equal to pi by a. So here they are given k is equal to pi by a, right. If you substitute here k is equal to the pi by a, so then dw by dk is equal to 4c divided by m whole power 1 by 2 into cos pi by a by 2, and a cancel. So therefore 4c divided by m whole power 1 by 2 into cos pi by 2. We know that cos pi by 2 is equal to 0. So therefore d omega by dk is nothing but group velocity is 0, right. So therefore option D is correct for 81, question number 81. Okay. Next, question number 82. In a divalent metal with BCC lattice, so this is important, BCC lattice, and lattice constant 2a, the electron density is given by electron density. So we know that electron density rho is equal to n effective into number of electrons in that metal. See, in a divalent metal, that means 2 electrons are there. Okay, so there will be a 2 electrons, that means 2 free electrons in outermost shell divided by n. Okay, so sorry, a cube volume, so which is equal to a cube. A is nothing but lattice constant, and a cube is nothing but volume of a unit cell. Okay, and n effective is nothing but number of lattice in a unit cell. Okay, so in a BCC structure we know that number of lattice point in a unit cell n effective is nothing but 2. Okay, next, number of electrons per atom is 2 divided by a cube. So lattice constant A is given, so that is 2 into 10 to the power of minus 10. So therefore 2 into 10 to the power of minus 10 whole cube. So let us take this as 4, 2 to the 4, 4 to the 8, okay, into 10 to the power of 30, 4 in the 4 to the, so 1 by 2 into 10 to the power of 30 meter cube, 10 to the power of 30 per meter cube. But so here in the option, so it is that in terms of centimeter cube. So in centimeter cube, if we take divided by, we can convert meter to centimeter, so it is 10 to the power of 2 centimeter, right? So 1 meter is equal to 10 to the power of 1 meter is equal to 10 to the power of 2 centimeter. So therefore which is equal to 1 by 2 into 10 to the power of 24 per centimeter cube. So 1 by 2 into 10 to the power of 24 per centimeter cube. So option C is correct. Option C is correct. Okay. So next, question number 83. Electrical conductivity sigma is given by sigma is equal to n e square tau divided by m, with the symbols having their conventional meaning. If E square by H is the unit of electrical conductivity, H being Planck's constant, which of the following is dimensionless? Okay, so here E square by H is the unit of this electrical conductivity, so for sigma. So this is very easy question. So we know that sigma is given. So what is sigma? N e square tau by m. Sigma is n e square tau by m, and sigma is also equal to e square by h. So that is also given. If E square by H is a unit of electrical conductivity, sigma. So therefore if we equate this equation, we will get n E square tau by m is equal to E square by H. E square by H. So therefore E square cancel. Therefore you can write that as n H tau by m. N H tau by m. I am writing once again. So n H tau by m. So this is the answer. NH tau by m. Where is there? So option B is correct. See, very easy. Next, here the question number 84. Seebeck coefficient S is related to the Peltier coefficient pi by the Kelvin relation. We know that the Seebeck coefficient is S and Peltier coefficient is pi. The relation for Seebeck and Peltier coefficient. Okay. So it is also a very easy question. We can easily observe that. So pi is equal to ST. You should remember this. Pi is a Peltier coefficient and S is the Seebeck effect. So the coefficient, the relation for Peltier and Seebeck is pi is equal to ST. So here they asked for Seebeck coefficient, right? So therefore S is equal to pi by T. So option A is correct. So this is question number 85. In the following, there is an assertion A and reason R. So assertion A gives that in pure semiconductor, the temperature depends on resistivity rho is given by ln rho is equal to 1 by T. So this is the assertion given. They are given the statement. So the statement is in a pure semiconductor, the temperature depends on resistivity rho is given. That means the resistivity and the relation of resistivity versus temperature is given. Okay, that is ln rho of 1 by T. So we should verify this whether it is right or wrong. So why this statement is, they are given the reason that the resistivity, the intrinsic carrier. So this is intrinsic carrier. Intrinsic means pure semiconductor. It does not dope this semiconductor with any other semiconductor material. Okay, so intrinsic means it's a pure semiconductor. So in intrinsic carrier concentration, the intrinsic carrier concentration increases exponentially with increasing temperature T. That means with the increased temperature T, the intrinsic carrier concentration is also exponentially increases. So which of the following is true? Okay, so these are the codes given. A is correct and the R is wrong. That means statement is correct and the reason is wrong. And for B, A is wrong and R is correct. So actually they are given statement is wrong but the reason is right. In option C, A and both correct but R is not the explanation for A. Okay, so both is correct but there is not a definite explanation, they are mentioned like that. And option D, A and R both correct and R is the explanation for A. So actually we know that in a pure semiconductor, okay, in pure semiconductor, okay, so N intrinsic carrier is directly proportional to e power T. Okay, so therefore conductivity is directly proportional to e power T because conductivity sigma is directly proportional to Ni, right? So then we also know that sigma is inversely proportional to resistivity. Therefore 1 by rho is directly proportional to e power T. So then rho is equal to 1 by e power T. So then rho is equal to e power minus T. If you take ln on both sides, so then ln rho is equal to 1 by T. Ln rho is equal to 1 by T. Okay. So therefore, see, this is Ni is directly proportional to e power T. Reason says that both, see the reason, the intrinsic carrier concentration increases exponentially with increasing temperature, right? So here it is exponentially increases, we can see here, and therefore it is also inversely proportional to T, the resistivity, that also we can prove. So therefore A and R both are correct. In pure semiconductor, the temperature dependence of a resistivity rho is given by this one, and the intrinsic carrier concentration increases exponentially with increasing temperature. So both reasons, both are correct. So option number D is correct. So this is question number 86. The Hall effect experiment, the Hall voltage VH is observed when current I is passed. Okay. So the Hall effect is observed when current I is passed for a sample material through the sample placed in a magnetic field B. If the current is doubled and the magnetic field is decreased by 4 times, then the new value of the Hall voltage is. So suppose let us take a specimen, a sample. Okay. For this sample, we are applying magnetic field and we are passing current I initially. So then the Hall effect we observed is VH. Next, VH is observed. This sample is placed in magnetic field. Okay. Now, if the current is doubled, current I is doubled. So that is I is equal to 2I now. Next, or I1 is equal to 2I1. And the magnetic field B is decreased by 4 times. So that means B, see, initially it is B1, now it is 4B1, sorry, 4 B1 by 4, the new B1. Therefore, next, so from these relations we should calculate VH, new VH. So we know that VH is directly proportional to current and magnetic field. So therefore VH is directly proportional to, this is increased with 2, double, current is increased with 2 and the magnetic field decreased with 4. So 2 1s are 2 2s are. So therefore VH is directly proportional to IB by 2. So this IB is nothing but VH. So the new V is decreased by VH by 2 times because BI is VH. Okay. So BI is nothing but VH. So we can see this relation. So VH by 2. So option A is correct. So which of the following property of a superfluidity is correct? See, options given: it exhibits zero viscosity, it has very low thermal conductivity, it can be described by a two fluid molecule. So this is molecule. Next, it exhibits the fountain effect. Actually, for superfluidity, like a superconductor, in the superconductor we can observe zero resistivity. So here in superfluidity we can observe zero viscosity, and it has very low thermal conductivity, correct. It exhibits the fountain effect, correct. So it can be described by two fluid molecules, no. So option C is correct, because which of the following property they are asked not correct for superfluidity. So option C is correct.